So now, in this video, we have a 555 timer. You'll hear clicking. That's the passive buzzer right there. And we have LEDs to also indicate the state of the output right there. Sorry, the printer didn't print it very well when it came to the black. But in any case, it is mostly dependent on how much light is falling on it. Hopefully you can hear that plenty fine. If I pluck this timing capacitor, we can quickly change the timing. So now it's more like a buzz. So now we have two things that the output is going to be doing. It's going to be alternating LEDs and then clicking. I guess I intended this to be a speaker in the original video that I made with this, but passive buzzer will work basically the same. And then we got the capacitor there because we don't want current to keep flowing. We just want it to flow enough to make a click in this case right there. So I'm going to take this jumper, this black jumper right there, and we're going to go to 3 right there, the output pin 3, and just go up there, give us a spot to put the LEDs. We're going to do that first. And by the way, I'm using the system where if these wires are connected, they just touch each other right there. You can build a little jump over one wire when you don't want them connected. You can do that system. There's also a system where when they're connected, there's a dot, and when they're not connected, there is no dot. That happens. That's another way that you can draw it. So we got the blue LED. I'll put that one up on top. Longer lead the anode towards positive, shorter lead the cathode towards negative. When the output is low, it'll light up. And then the red LED. We wire it in the same direction right there, but we put the anode, the longer lead, to the output, shorter lead the cathode down one spot. Red LEDs are not as bright as blue LEDs, so we're going to use a 220 ohm resistor to protect it, and a 1000 ohm resistor, make sure I put it in the right spot, to protect the red LED when the output is low. Of course, the blue LED when the output is low. And 1000 ohm resistor right there, 220 for the red. You can see them wired up in that way right there. So now for the speaker or buzzer, we're going to use a passive buzzer in this case. Active buzzers, when you apply power to them, they buzz automatically, and you don't have to do anything. You just apply power. Passive buzzer, you actually have to have changing voltage to get the click. So we're going to put the positive side of the capacitor, because it's polarized right there, to the output, and then the more negative side, we're going to go across right there. Then we got the passive buzzer, and there's a plus and minus on the back. I don't think that's, yeah, there you can see plus and minus, but there's also a plus on the front. So again, we want to put the plus towards the output, and because down here is ground, that's the most negative voltage right there, so that's where you would put the more negative side of any component that is polarized. So high output, it doesn't get the full 5 volts, but like 3.5 volts will push current that way, making a click, and also light the red LED. It can provide plenty of current to do both of them. When we get a low output, then the capacitor will discharge right there, bringing current the other way through the passive buzzer, and the blue LED will light up going that way. So now, pin 2 and pin 6 need to look at the capacitor voltage at the same time. And again, if the lines are touching, they are connected. I would have made a little jump if they weren't. Everything that the lines coming together, if they're coming together, they're connected in this particular circuit. So be aware of that. Now, we got 2 and 6 tied together, and I don't know why it doesn't want to stay focused there. We're going to set a minimum charging current with the 220 ohm resistor based on the 5 volts right there. It also connects directly to ground, this resistor, when the output is low, because the discharge pin, pin 7, also connects directly to ground at that time. So we have to take that into account when we pick what value resistor to use. So I use 220 usually as a minimum when I'm going to put a full 5 volts across it. And light dependent resistor, that adds resistance while the capacitor charges and provides the resistance when the capacitor discharges. And again, I kind of like, for this demonstration purpose, the 47 microfarad capacitor value if I just want clicks. And the 2.2 microfarad capacitor seems to do a pretty good job at getting an okay buzz for this demonstration circuit. So now, pin 4 is the reset pin. If it sees a connection to ground, it's going to hold the output low no matter what you do. So we put it to the positive side of the supply in order to disable it. It will not do anything. It will never reset the 555 timer as long as it's connected to the positive supply. So now, of course, while I was wiring it up, I didn't have the power applied, and I bumped this current up a bit. I didn't have the capacitor when I was testing this out, and a lot more current was flowing. It made it so the circuit didn't work. But with the capacitor, we still have like short bursts of current, but it won't be as bad. But in any case, there you can see. That's kind of an estimate of how much current's flowing. It's actually going to be a bit higher or lower at times. But you can see we demonstrated there. That's with the 47 microfarad capacitor, and this flashlight stays on steadily in the front. Right there, it doesn't have a side light. My other flashlight, the front light turns on and off rapidly. I gotta turn on the side light to have a steady light. But in any case, there you go. Demonstrated the circuit again. To end this, after we build it, make sure we builded it properly. If you make a mistake, that's usually when you find out when you turn it on and it doesn't work. So always turn it on and test it when you're done. But in case, that's it. Thanks for watching. Make sure you check out one of the other videos I'm posting on the screen and check out links down below. They all help out a lot. I'll see you in the next video.